Hey yo, it's your boy Hove, and this lesson gonna be on the surface area of pyramids and cones, alright?
So as you know, we talked before about the surface area of, here's a triangular prism, but we talked about right prisms and cylinders, lateral surface area, which is the surface area of the sides, and then total surface area, which includes the bases. So today we're going to focus on pyramids, right here, and cones. As you can see, we're going to do lateral and total surface area. Just take a moment, look at this rectangular, maybe it's a square pyramid, but I don't know, so I'll say look at this rectangular pyramid. Obviously the base is this rectangle, which means the lateral sides would be these triangles. So that's a lateral side right there. Here's another lateral side. There's the third one, and there is the fourth one. So 4 triangles for the lateral sides, 1 for each side of the base. There's side 1, right, 1, all right, 2, 3, 4. So if my base has 4 sides, you can see there are 4 triangles that get formed in this pyramid. So the idea is, if I were to then take So here's the first example. You don't need to copy this down. It's actually in your ICW. It's example 1A, so take a second turn to find it, but the picture should be there for you already. So let's just set this up. You know my style. I'm looking for TSA, and I'll just notice based on this base here, this is a pyramid with a base that is square. So let's set up TSA. So as we know, the total surface area is all the lateral, or the sides, or the area of the sides, plus the area of the base. We're used to saying bases because prisms had 2 bases, but just notice this one only has 1. So let's deal with the hard stuff first, the lateral surfaces. Convince yourself that there are 4 sides in the base, which means there are 4 lateral sides, all 4 triangles that will all look exactly the same. They'll all be congruent to this blue triangle. So let's just do a calculation of that. So the LSA will be 4 times the area of the triangle. Okay, what's the area of a triangle? 1/2 base times height. So let me see, what is the base of this? I believe the base is given to me as 10. And now I need the height. Well, the height is also given to me. The height of the triangle is right there. It's 13. So is that the height of the pyramid? No, the height of the pyramid would be something like this. But that's inside the pyramid. I don't really care about that. I'm trying to find lateral. I'm just on the side here. This 13 is the height of this triangle, so that's what I'll use. Boop, 13, fit it in there. And I think if we calculate this, we get 260. So I'll go back up here. My LSA then is 260 plus I need the area of the base. Well, we said the base was, again, this square. A 10 by 10 square. To find the area, you do length times width, or side times side. So it would be, hopefully you're thinking 10 times 10, which is, also you may have called it 10 squared. All right, what am I trying to do here? I'm trying to zoom. And can I move this? All right, I don't know what I'm doing here. All right, so this equals 260 plus 10 squared, which is 100. We end up getting 360, and this is area, so I will say square inches. And we are done. So just as a recap, TSA, like always, is your lateral area plus the area of your base. We just have one base here. You notice it's a square. So to find the area of the base is the easy part. It's a square, so you just do side times side, 10 times 10, which gives you 10 squared, which is 100. And LSA we found was 260 because we saw that there were 1, 2, 3, 4 triangles for the lateral side. So 4 triangles. Each triangle was the same. It was 1/2 times 10 times 13. 1/2 base times height. All right, 1B, they also ask us to once again find the total surface area. So TSA is the name of the game. And remember that TSA is your lateral surface area plus the area of your base. Let's do the hard part first. Oh, I haven't annotated fully. My bad. What kind of base do we have? I believe it's a hexagon. All right, so if I look, that means n, my number of sides, n, is 6. I have 6 sides, so I'm going to have 6 sides of my base, so I'm going to have 6 triangles for my lateral sides here. And if you look, let's see, they give me the height of the triangle is 8. Just realize that that would be the same as, I'll show it right here, the same as here. So the height of my triangles is given as 8. Do I know the base of my triangles? I'm going to assume they meant for this to be a regular hexagon, and by telling me this is 5, they meant this is 5, or else this question is impossible. So I'll say, to find the LSA, I'm going to do 6 times the area of the triangle. And each triangle follows the format 1/2 times the base, which we said was 5, times the height, which they gave us as 8. I believe then we can find 120, in case you care, square centimeters for the lateral surface area. So that is what I get when I take the area of all 6 sides. So let me write TSA down here a little bit. I need more room. Okay. So I just set this up. I have TSA is LSA plus the area of the base. So now the question becomes, how do I find the area of the base? Well, I know the base is a hexagon, and so I know a nice little formula to find the area of a hexagon. And that formula is 1/2 AP, where A is the apothem and P is the perimeter. So this is how I find the area of my hexagon. So I have 1/2. Do I know what my apothem is? Aha, they gave it to me. 4.3. And again, the apothem goes from the center of the base to the side. So it goes perpendicularly from the center to the side. So they tell you that's 4.3, so I stick in 4.3. And the perimeter, I need the perimeter of this hexagon. Well, again, I'm assuming it's a regular hexagon so that I can actually find it. If each side is 5, and there are 1, 2, 3, 4, 5, 6 sides, I believe the perimeter would be 30. And I did that by doing 5 times 6. Seriously? 5 times 6. Oh, there we go. All right, so the perimeter is 5 times 6, 30. All right, so let's look at this area of the hexagon. We have 1/2 times the apothem, 4.3, times 30, which was the perimeter. So there's our formula. Let's clean this up. I think you get 64.5. So when I add up all this together, I get 184.5 square centimeters for my area, surface area. So I just wanted to bring this up really quickly. Example 2a, I'm not going to work all the way through it because I don't want the video to be too long, but I want to point out they think that they can trick us here by not giving us the height of the triangle. Like I don't have the height of the triangle. So when I try to set up my lateral surface area, I know the base of my triangle, but I don't know what the height of the triangle is. Well, I actually can figure it out. So I drew in my height here, the height of the triangle. That's the height of the triangle, I'll say. And what you may notice, if you sort of can shift your eyes around, is that that actually forms a right triangle that cuts through the center of the pyramid. So while they thought they were being slick, they weren't being that slick, because I can actually use this right angle. I know the height. Let me pull this triangle out here. I know the height of the pyramid is 22. I know the height of the triangle, the thing I'm after, is the hypotenuse. So now the question becomes, do I know how long this is? Because if I do, I can then just use, you guessed it, the Pythagorean theorem to find out how long the hypotenuse is, how long the height of the, like what the height of the triangle is. Then I'll just do 1/2 base times height. Here's the base. There's the height. Do it times 4 to get the lateral surfaces, and then I'll be home free. And so now it seems like we've run into a little bit of a speed bump because we don't know what this length is. But if you picture again what they're doing, the height goes to the center of this base, which is a square. So if you're going from the center of the square to an edge, well, the entire length of the square would be 22 inches. Here I'm just going halfway. Well, what is half of 22? 11. And so if you are having trouble seeing this, just the perspective of it, here's what they're giving us. They're giving us a square base that's 22 by 22. And this point right here would be in the center, right there. And then this segment in green would be right there. And I'm saying, if you know that this whole thing is 22, this whole side is 22, if you want to just go half of it, it's just going to be going 11. So once we have this found, that is 11 and this is 22, I can actually find out what the height of my triangle is. Again, we're just using this right triangle right here. We're using Pythag. Some of the numbers you'll get, that's what you should get when you find the height of the triangle. When you then set up TSA, you will get 4 times this quantity that you see right here. Each of these represents the area of a lateral side, or I'll say area of a triangle, or each triangle. That's what you see in parentheses here. And then plus 22 squared, I said 22 times 22 for the area of the base. All in all, when you work this out, you would get one of these two answers, either 484 root 5 plus 484 if you were using the radical 5, if you just kept it that way. Or if you use decimals, you'd get 1,566-ish square inches. At this point, please pause the video. You've been watching for like 10 minutes at least, longer than that. And so your attention should probably be wavering because this is a long time to just watch a video. So pause the video here and start working through some of the pyramid surface area questions in your ICW. So take like 4 or 5 minutes to do that.